but they are not well-known services, right? So they can use the registered port number, and dynamic port number is basically used by the client process, right? So which is dynamically and randomly assigned to the client process, right? So in order to make the communication possible between client and server, okay? So what you need to do in order to make a communication possible, now you have to specify two things: the remote host IP address and remote port number, and you also need to specify the local IP address and local port number, okay? So remote IP address and port number together basically defines as what is referred as the socket address, right? So you will basically require a socket address if you want some process on a particular machine A to communicate with another process on certain machine B. Then what you need is you need to have a socket address, which is nothing but it's a combination of IP address as well as the port number, okay? We also seen in the last slide that the role of the transport layer is basically kind of a multiplexer and demultiplexer, where the transport layer actually receives data from multiple processes and then converts it into the single flow of packets, and these packets are in turn converted into frames, and these frames are transmitted over to the network, right? On the other hand, when we receive the continuous flow of packets or frames, the job of the transport layer is to segregate or to bifurcate this particular sequence of the flow of packets into set of data which is meant for a particular process, right? So receiving data from the process and combining into the single flow, similarly receiving the single flow of data and then segregating them into the process wise data, so that is called the demultiplexing process. So therefore the job of the transport layer is also to provide the multiplexing and demultiplexing kind of facility there at the process level, right? So that is also another view how you can visualize the role of the transport layer in TCP/IP stack. Okay. So today we are going to see what kind of services are provided by the transport layer. So we see that we already discussed this, that the transport layer is basically providing two different types of services. One is called the connection oriented service and the other is called the connection less service, right? The connection oriented services are basically the reliable services, right? And the connection less services are also referred as the unreliable services because they do not check for error or they do not check for any kind of loss of packets, right? So in order to implement a reliable and unreliable service, we have already seen this mechanism in the previous lectures or in the previous sessions also, that when we are talking about the data link layer, then the data link layer, we know that, okay, it is also providing a reliable services between two nodes, right? And what do you mean by reliable service? The reliable service is basically obtained by using what is referred as the acknowledgement and sequence number, right? So you transfer a packet with a particular sequence number, and when the receiver receives that packet without any error, the receiver is supposed to send an acknowledgement number back to the sender, and that is how the sender came to know that the packet that is being transmitted, it is received on the receiver side without any error. So this is what we mean by reliable service, right? So any service that implements the sequence number and acknowledgement number based mechanism, that particular kind of service can be referred as the reliable service, okay? So at the transport layer, we provide both connectionless and connection oriented service, and the connection oriented service is also implemented as a reliable service. That is, it is also implemented using the sequence and acknowledgement mechanism, right? Whereas the connectionless service, which is at the transport layer, it is implemented in the unreliable way. That is, it does not implement any sequence number or it does not contain any acknowledgement number, okay? So we have already seen that the error checking mechanism, there are different error checking mechanism which are happening in the TCP/IP stack. So first level of error checking, which is happening at the data link layer. So we already know that the data link layer frame basically contains a CRC checksum, and the CRC checksum is basically responsible for verifying whether the frame contains any data or any error in the transmission or not, right? So CRC checksum is the first level of error correction mechanism that which is implemented at the data link layer. However, we do not have any error control mechanism implemented at the network layer, and therefore now at the transport layer we need to implement this particular error correction mechanism, right, in order to provide the reliable delivery. So at network layer, if you can verify that we only have a checksum, header checksum, and the header checksum is only responsible for checking whether the IP header contains any error or not, right? The header checksum does not actually provide any information on whether the data inside this particular header contains an error or not, right? So we do not provide any mechanism or any error checking condition on the network layer for data, right? We are only providing the error verifying mechanism at the network layer, which is to verify whether the IP header consists of any error or not, whether the IP header is correct or not, right? So the header checksum information which is available in the IP header only talks about the header itself and doesn't talk about data. So basically, the network layer, we do not verify that whether the data contains any error or not, right? Now, in order to provide the reliable service and unreliable service at the transport layer, it is very much essential that the error checking mechanism has to be implemented now back at the transport layer. Okay, so data link layer and the physical layer, we do provide an error checking mechanism. At a network layer, we do not provide any error checking mechanism. So whatever data which are going here at this level, we do not do any kind of error checking. And then again, in order to provide the reliable services at the transport layer, right, we need to implement an error checking mechanism. So what is this purpose? Why we need to have two different types of error checking mechanism? Why there is error checking at the data link layer and why there is error checking again at the transport layer? I hope you try to understand this, that at the data link layer, the communication is between one hop to the next hop, right? So when I provide the error checking mechanism, when I provide the reliable delivery, when I provide the sequence number and acknowledgement number, the only thing I am making sure is that the data which is going from this node to this node, it is received successfully, right? But I cannot do any comment on what is the status of the data when you are starting it from the original source to the original destination, right? Data link layer, the scope of the data link layer is to only talk about that particular link. The scope of the data link layer is to only verify the successful delivery of data between the current destination and the immediate, between the current source, immediate source and immediate destination. But whether the data was reaching from the actual source to actual destination, whether the data is reaching intact or not, whether the data is containing any error or not, data link layer is not responsible for verifying that end-to-end error checking mechanism, right? So error checking mechanism and flow control mechanism, or this reliability mechanism that we implemented at data link layer, they are only limited for that particular hop, or rather they are only limited for the immediate source and immediate destination. They do not provide error control, or they do not provide reliable delivery of data between the actual source and actual destination, right? So sometimes students are confused that why there are two level of sequence number and acknowledgement number, why there are two levels of error correction mechanism. But just to emphasize it again, that whatever sequence number and acknowledgement number mechanism we are implementing at data link layer, they are only ensuring the successful delivery between the nodes, right? Whereas the sequence and acknowledgement number that we are implementing at the transport layer, it ensures the successful delivery of data between the actual source and actual destination, right? So this is the difference between these two, right? The error control mechanism and flow control mechanism implemented at data link layer, and the error and flow control mechanism implemented at the transport layer. Okay, so what are the protocols available at the transport layer? As we already discussed, that there are two primary protocols which are available at the transport layer. One is called the TCP protocol, that is called transmission control protocol, and the other is called a UDP protocol, that is called user datagram protocol. So TCP protocol is basically a connectionless protocol, whereas a UDP protocol is basically a TCP protocol is connection oriented protocol, and the UDP protocol is basically a connectionless protocol. Okay, so so initially when the TCP/IP protocol stack was designed, there was only one protocol at transport layer and there was only one protocol at network layer. So the protocol available at a transport layer is TCP only, whereas the protocol available at the network layer was IP only, and therefore the name of this protocol suite was given as TCP/IP. However, as you know, as the time passes on and the designers do realize that there has to have a protocol which is operating in a connectionless mode and providing the services in the connectionless environment, so therefore they added this UDP protocol here. So UDP was added afterwards, right? Originally there was only one protocol in the TCP/IP stack, and that was the transmission control protocol, which is a kind of connection oriented protocol. Okay, so connection oriented and reliable protocol, right? So it provides a reliable delivery of data, and it implements a connection oriented mechanism, that is, it establishes the connection before transmitting the data. Okay, on the other hand, the UDP protocol is a connectionless protocol, that is, it does not implement any connection mechanism, right? It does not establish any connection before transmitting data. At the same time, UDP is an unreliable service. Unreliable service means that it does not provide any acknowledgement, it does not provide any sequence number, or it neither verifies neither ensures the successful delivery of data on the other end. It simply sends the data and then forgets about it, right? Something like that. So this is called the UDP protocol. There are other protocols also which are implemented at transport layer, namely the SCTP, that is a secure transport protocol. That is one which is very popular. And there was another popular protocol that is called RTP, that is called real-time transport protocol, right? So this RTP protocol is basically designed to deal with the multimedia content, like for example, audio and video content. So when you are trying to stream the video, or you are trying to send the audio content or video content on the internet, that it is expected that you deliver this content with minimum overhead, data overhead, and with maximum speed as possible, so that you don't have any lagging on the receiver side, right? So this RTP protocol is designed in such a way that to deal with the multimedia content on internet, right? So RTP, that is the real-time transport protocol, is another protocol which is very popular at the transport layer. However, for the sake of discussion in this particular course, we'll only be talking about the TCP protocol, and we'll only be talking about the UDP protocol, right? So interested users can actually go and search what is SCTP protocol and what is RTP protocol. So once you understand the functionality of TCP and UDP, then probably it would be easy for you to go and check the functionalities of RTP, how RTP is operating, and functionality of SCTP, how SCTP is operating, right? So SCTP is basically designed to provide an additional layer of security by implementing the data encryption algorithm at the transport layer itself. So it is making sure that whatever data you are sending out through the transport layer to the network layer, that all this data is encrypted, right? And when you receive an encrypted data, it is properly decrypted and handed over to the higher layers, right? So basically, it provides a kind of data security by encrypting the data into a format which is not understandable or readable by the other user, right? So even though your data is captured in between, or your data is, some intruder is trying to hack into your system, but still hack into your network, but still they won't be able to see the data because the data is basically in the encrypted form. So we'll try to talk about encryption and decryption in a great detail, maybe in the last session of this course, right? But this is what we mean by the secure transport protocol. It leverages the encryption decryption functionality. It embeds the encryption decryption functionality within the transport layer itself. Normally, this encryption decryption is done by the application, right? So the current trend is that the application is responsible for encrypting and decrypting data before it sends the data to the transport layer. But with this protocol SCTP, now this burden of encrypting and decrypting data has been laid off from the application side, and the transport layer itself is taking care of this data. And why we need to do this? Because we don't have any separate layer for presentation and session. So if you remember that in the OSI layer, there are two different layers, right? That is, one is a session layer and the other is a presentation layer. And we discussed that the presentation layer is basically responsible for encryption, decryption, data compression, uncompression, and so on. Okay. But since we don't have any such presentation layer in TCP/IP, the job of encryption and decryption either is to be performed by the application layer, or it is required to be performed by the transport layer, right? So this is what we mean by the SCTP protocol. Okay. So we'll first of all start with the UDP protocol, that is called the user datagram protocol. And as I said, that the user datagram protocol is a connectionless protocol. What do I mean by that? It simply means that it does not establish any connection before transmitting the data. And the second is that it is unreliable transport protocol. What do I mean by that? It does not track any packet, right? Which packets are sent and which packets are successfully received by the receiver. It does not track this thing, right? It does not provide any sequence number and acknowledgement number mechanism, right? See, when I say reliable delivery, means we are tracking each and every packet, that when a packet is sent, whether the same packet was received by the receiver successfully or not. And how do we make sure? We make sure this reliability with the help of the sequence number and acknowledgement number, right? So the sender will send a packet with a sequence number, and the receiver has to acknowledge that, okay, this particular packet is received successfully. So basically it has to send an acknowledgement back to the sender, right? So once we have this sequence number and acknowledgement number mechanism, we make sure that whatever packet we are sending, those are the packets which are successfully received by the receiver. But in case of UDP protocol, we do not implement any of this mechanism. We do not implement sequence number and acknowledgement number mechanism, and therefore UDP protocol does not provide or does not guarantee any reliability of transmission, or does not guarantee any reliable delivery of data on the other end. So basically, a UDP protocol does not add anything extra to the IP layer except to provide a process-to-process communication, right? So we already discussed that our IP protocol, which is operating at the transport network layer, this particular IP protocol is also connectionless, and this particular IP protocol is also unreliable. That is, before sending data, IP layer do not establish any connection, and IP layer when sends a packet on the other end, it does not expect any acknowledgement for that particular packet back, right? So IP layer is not implementing connection oriented mechanism. It is connectionless as well as it is unreliable, right? So as the UDP protocol. So UDP is also connectionless and unreliable. IP is also connectionless and unreliable. So I would say that UDP doesn't add anything into the IP. The only thing that it adds is that IP is basically providing a device-to-device communication, whereas UDP is providing the process-to-process communication. So the only layer that UDP adds on the top of IP is that it provides a process-to-process communication. It makes it feasible to do this process-to-process communication instead of host-to-host communication. Otherwise, all the functionalities of UDP are exactly same as IP, right? It doesn't make any difference as far as the other services are concerned, right? So the only addition to IP is providing a process-to-process communication with the help of port numbers. So sometimes you may wonder that if UDP is so powerless, it doesn't provide connection, it doesn't provide reliability, even we are not sure whether the data sent by UDP will be received by the other end or not. Why do we use UDP protocol at first place, right? Why do we use it, right? What is the purpose? And the purpose is that since it does not implement connection mechanism, it does not implement the acknowledgement and sequence number mechanism, it has the minimum overhead, right, over the system, right? So you already know that when you have a sequence number and acknowledgement number, you have to send the packets, right, with certain sequence number, and then you have to wait for the acknowledgement. And because of this waiting time, the bandwidth is wasted, right? Because you cannot utilize the channel enough with the full capacity, right? Until or unless you don't get an acknowledgement of the previous packets, you cannot send new packets in, right? So even though the channel is available, even though there is some data which the host want to send, right, but still you cannot send it. Why? Because you didn't receive acknowledgement of the previous packets or the previous data that you have sent. So sometimes this flow control, that is this acknowledgement and sequence number mechanism, becomes a bottleneck, right? And because of that, even though there is a data available, even though there is a channel available, but still we cannot transmit, that is, we cannot utilize the channel, right? So therefore the efficiency or the utilization percentage of the channel reduces because of this mechanism, right? So yes, I mean, we do implement this connection oriented and this reliable service we do implement, but they comes with a price, right? So the price that you need to pay is the additional overhead or the additional cost that is incurred in implementing these solutions, right? But since UDP is not implementing any of this, UDP has the minimum overhead, right, as far as the computation is concerned. So for sending small messages, so therefore UDP is basically very suitable for sending small messages, right, if the reliability is not desired, right? For example, I want to send an audio signal, right? So audio signal can be divided into small samples, right? And those small samples, the entire audio file can be converted into number of samples, and those samples can be sent on the other end, right? Here I can expect that, okay, even though certain samples are missed out, or even though certain pixels, if I'm trying to talk about an image patches, so I can divide my image into number of patches, and then I can send that images, right, throughout the through the internet. And I know that even if some of the pixels are going here and there, even some of the samples or the audio samples are corrupted, right, but still it is fine. Still you can actually work with the remaining pixel, or you can work with the remaining data samples, and then you can interpolate what is going to be the value of the missing data sample, right? So that is possible. So reliability is not a very stringent requirement there, even though certain data is lost, or even though certain data is not received properly, but still you had a mechanism to recover that data with the help of interpolation or something, right? In case of pixel, we know that if we do not receive certain pixel, you can always estimate the value of the pixel from the neighborhood, right? So the color value of the pixel is actually same as the color value or the average color value of the neighborhood. So you can always estimate that missing pixel value, right? Similarly, in the voice signal, we know that the voice signals are not changing rapidly, right? So therefore, if certain data points are not there, then we can actually use some kind of interpolation technique in order to find out that what data points are missing and what could be the probable value of those data points, right? So what I'm trying to say is that if reliability is not a very stringent requirement, you can afford to lose some data, right? But what you want is you want the minimum overhead. You want your data to send as fast as possible, right? And the data is very small in terms of size, so that it can fit it into the single segment or it can fit it into the single packet. Then in this particular case, the UDP protocol would be more appropriate to use, right? So it is less interactive between the sender and receiver as compared to TCP and IP. In fact, there is no interaction, right? The UDP sends the data and then forgets about it, right? Similarly, receiver receives the data, checks about whether the data is okay or not. If it is not okay, receiver cannot simply do anything. It simply discards that data and that's it. It doesn't. It cannot go and tell the sender that whatever data that you have sent is not correct, right? There is no interaction at all, right? It is just send and receive. There are only two primitives. There are only two service primitive in the UDP protocol, that you send the data and you receive the data, nothing else, right? So there is no further communication that happens between the server and the receiver, right? So sender and the receiver. So there is very less interaction between the sender and receiver in case of UDP. So these are some of the algorithm like echo. Like echo, you know that echo is a facility which echo back whatever message you type, right? So if you type ABC, then the echo server will send it back. So echo server is just to test the connection, or just to test whether the network connectivity is there or not, just like ping, right? So so echo actually do not have any application as such. It is just echoing back whatever message you type. It is just sending you back. So it is only mostly used for the diagnostic purpose. It doesn't have any real world significance, right, beyond that. But anyway, it is a very short message, and that message doesn't require you don't have that reliability constraint here. So therefore it is possible for you to implement the echo server mechanism using UDP, right? Similarly, you have a user active, number of active user, daytime server. Daytime server, we already discussed that you want to find the date and time, current date and time. So that is again a very short message that you want to send. So this can be done using UDP. Okay. So UDP actually only handles the packet where the entire data can be fit into the single packet, or the entire data can be fit into the single segment. Obviously, why? Because it doesn't handle multiple segments, and it doesn't have any way of connecting those segments together. So when you divide your data into more than one segments, right, you have to tell your receiver that, okay, this is the first segment, this is the second segment of the data, this is the third segment of the data, and then you combine them together, and then you generate the original data back. But since TCP is not maintaining any sequence number, therefore it is not possible for UDP to actually divide data into chunks and then regroup those chunks together in order to generate the original data. So if you remember, I told you in the previous class that the transport layer divides data into segments, and then on the receiving end, again you have to combine these segments together in order to generate the original data back. Because the processes cannot work with partial data. The process has sent the data, and the process has to receive the entire data intact as it is. So therefore, it is a responsibility of the transport layer now to divide this data into segment and to combine these segments again in order to form the original data back. But it is not possible with UDP. Why? Because UDP doesn't maintain any sequence number. So UDP doesn't maintain like, okay, this is the first segment of the data one, this is the second segment of the same data, and this is the third segment of the same data, and like that. For UDP, every segment is independent of the other segment. Just like your IP, right? At a network layer, we had an IP protocol, and we said that at an IP protocol, every packet is independent of the other packet. तो एक पैकेट में क्या डेटा है, उसका दूसरे पैकेट के साथ कोई लेना देना नहीं है, right? And the path which is taken by one packet, it has nothing to do with the path taken by the second packet. It could be very well possible that the path taken by one packet is entirely different than the path taken by second packet, right? Whereas the destination IP address of both first and second packet are same, even though you have a same destination IP address, but still it is very much likely that both the packet will follow two different paths, right? So TCP/IP, I mean, in the IP protocol, we have the packets are independent of each other. Similarly, in UDP also, we have these segments are independent. UDP segments are independent of each other. So when I say they are independent of each other, means they cannot contain data coming from the same source, right, and dividing into multiple chunks, right? So therefore, one of the primary requirement of UDP is that the message that you are sending and receiving through UDP, it has to contain the entire message should be contained inside a single UDP segment, right? If it is not the case, then you cannot use UDP protocol for it, right? If you need to divide your data into multiple segments and then you want to track, then in that particular case, you have to use the TCP protocol. Okay. So daytime server is a very simple server. It simply sends a request and receives a current date and time. So it can be done in a single segment. So therefore we use UDP here. Then there is something called quote service. Quote service means it gives you the quote of the day, right? So it gives you some kind of quotes, right? Motivational quotes, right, for a particular day, right? So that is also implemented using UDP because it's a very small implementation. Similarly, you have a BOOTP protocol. BOOTP is normally used when you want to have a server booting mechanism, right? That is, you want your local machine to boot from the server, right? From the operating system which is installed on the remote server, right? You have something called RPC, remote procedure call. Remote procedure call means kind of executing a function, but the function is executed or it is hosted on a remote machine, right? So you call the function, you pass the parameter using a UDP protocol, right? And then the remote machine will execute the function, will calculate the result, and after calculating a result, it will return the result again using UDP protocol. So that is called remote procedure call. So remote procedure call is kind of a utility that allows you to execute a function, but that function is actually hosted on a remote machine, right? So that is what is called the RPC. So similarly, you have NTP and you have SNTP, and there are so many other protocols which can be implemented using UDP. So looking at the header format of UDP, it's a very simple header format. Since you don't have much thing to go there, you only have 4 fields, right? So the header is only of 8 bytes, right? So 8 bytes, that is 16, so 4 bit here, right? So 4-bit nibble, you have the source port number, which is 16 bit, right? That is 2 bytes. Destination port number is again 2 bytes, 16 bits. So you get 4 bytes here. And then you have a total length field, that is a total length of the header as well as data, that is again 16 bit, right? And then finally you have the checksum, which is again a 16 bit checksum, right? So there are only 4 fields, right? Each field is of 2 byte, right? And therefore the total length of the header for UDP protocol or the datagram protocol is only 8 bytes. You have a source port number, you have a destination port number, you have a total length field, and then you have a checksum field, right? So the UDP length can be obtained by the length of IP length minus the IP headers length, right? So what is the length of this UDP packet? The length of the UDP packet can be obtained by looking at the IP length minus the IP header length, because the UDP packet is in turn accommodated in the IP packet, right? So the data part of the IP packet actually contains a UDP segment, right? So if you want to know the length of the UDP segment, you can find out that by actually subtracting the IP length, the total length of the IP packet, and then subtracting the header of the IP packet. Now, as far as the checksum is concerned, so the checksum is actually computed on not only on the source and destination IP addresses, but the checksum is actually computed on all the fields, including the source port number, the destination port number, the UDP length, as well as the data inside the UDP packet. And apart from this, it will also use the 32-bit IP address, source address, and 32-bit destination IP address, and it will also use the protocol field, and it will also use the 16-bit total length field, which is there in the IP header. So actually this information is available in the IP header, but in UDP we use this information in order to compute the checksum, so that we are making sure that the IP address and port number, the pair of IP address and port number is correct, and it is without error, right? Sometimes it may happen that the source number mentioned is correct, but the IP address is corrupted. Or sometimes it may happen that the IP address is correct and the source the port number is corrupted. So in such a situation, in both these cases, we will have the socket address not mentioned correctly, and in both the situation, we will not be able to deliver the data correctly, right?
So in order to make sure that the delivery of data is correct, we have to make sure that the both IP address is without error, as well as the port number field is also does not contain any error. So therefore, when we compute the checksum information in UDP, the checksum information is computed based on IP address also and based on port number also, right? So it's a source IP address, source port number, destination IP address, destination port number. Plus, we also accommodate the protocol field value, right? 16-bit UDP total length, that is the total length field of the IP header, and UDP total length field, right? So we include everything. And apart from that, we also include the data as well, right? So this checksum information, remember, this is not only the header checksum. So it does not only verify. So unlike IP protocol, where we are putting the header checksum only, and that is the checksum was only computed using the header information, just to make sure that whether the header obtained is proper or not. In this case, we are computing the checksum on the entire data, right? So checksum allows us to not only verify whether the header information is correct, but it also allows us to verify whether the data transmitted or contained inside the TCP or the UDP segment is also correct or not. Okay, so this checksum information is actually consists of data as well. So it will also use the data part in order to compute the checksum, right? So we have to make sure that it is a multiple of 16 bits, right? So if your data is not a multiple of 16 bit, then you have to add additional padding values just to make sure that your data actually is a 16 bit. It becomes a multiple of 16 bits. Why? Because your checksum is 16 bit. So therefore you required all the data on which you are computing the checksum to be the multiple of 16 bits, right? So that is how the checksum is computed here. So this information that is called the IP address, 32 source address or destination address and so on, these are sometimes referred as the pseudo header, right? Why it is called pseudo header? Because it's not actually the header information. It's not actually the part of the UDP header information. They are the part of the IP header information, but we are still using here at the transport layer, right, in order to compute this checksum value. So here is another example why we say that TCP IP is not very well designed, right? We if you remember in the very first or second lecture, we said that when we are comparing the TCP and OSI, we say that OSI is a very well designed, the service and primitives and protocols are well separated. It is following the layered architecture, that is the functionality of one layer is independent of the functionality of the other layer. Whereas on the other hand, TCP IP protocol is not very well designed. There is a lot of dependency between one layer and the other layer. And here is this example of the dependency. We said that the IP address is only used at a network layer, right? But here you can see that IP address is also required in the transport layer as well. Why? Because if you don't have an IP address, you won't be able to compute the checksum information at the transport layer of UDP. So therefore, you can see that in this particular case, there is a dependency of the transport layer protocol on the data which is available at the network layer protocol, right? So this is what it mean by breaching the regulation of layered architecture. So layered architecture basically says that one layer should be independent of other layer. One layer should not be use any data or any parameter which is defined and controlled by the other layer. But in fact, this condition is not being satisfied here, right? Anyway, so this is the pseudo header, and using the pseudo header as well as the source and destination port number as well as the data, UDP will compute the checksum, right? And this particular checksum is then accommodated inside the field. So for example, this is what the idea is, right? You have the source address as this, destination address as this, protocol value is 17. Why? Because it's a UDP protocol, so the value is 17. And then the length of the total length field of the UDP packet is 15, right? 15 bytes here. And then we have the source port number, the destination port number, right? And then finally we have this data here. So what is the data? Data is TEST ING, testing. So testing is the data that we are sending here, right? So we are dividing them into bytes. So this is first byte, second byte, third byte, fourth byte, and so on. But in order to make it a multiple of 16, that is in order to make the multiple of 2 bytes, we have 1, 2, 3, 4, 5, 6, 7 bytes here, right? Which is not a multiple of 16, right? So therefore you have to add zeros here. So you have to add 8 zeros here so that you can make this two coming together, you can make it equal to 16 bits, right? So this is 16 bit, T and E form 16 bit, S and T form 16 bit, I and
I and N forms 16 bits, but G is actually only 8-bit data. So in order to make it equal to 16-bit, you have to add zeros, or that is called padding. You have to pad this data with zeros in such a way that the last byte is actually consists of 16 bits, right? That's a combination of two 8-bit values, right? So now you can put up this thing like this. You have this 153.18 is a 16-bit value, then 8.105 is another 16-bit value, then you have 172.2 is a 16-bit value, 14.10 is another 16-bit value, and then you have all zero here, 8-bit 0, and then 8-bit value for the protocol field here. So 0 and 17 forms a 16-bit pair, and up to etc. so on. So when you add these things together, right? So these are the 16-bit representation of data. When you add them together, what you get is the sum, right? And then you can invert them, right? You can convert or complement them. What you get is the checksum value here, right? So that is how the checksum value is computed. So one thing is that the checksum value is actually computed on data as well as IP address as well as the port number, right? So if any of this thing is incorrect, whether the IP address is corrupted or the port number is corrupted or some part of data is corrupted, then your checksum will not match. And if the checksum will not match, then the receiving process will actually discard that particular packet. So what happens to that discarded packet? Nothing. We do not take any step, right? It is just simply discarded, right? So the sender do not have any way to know whether the packet that is received is actually received without error or the packet is discarded due to some error, right? So that packet is simply lost. That data is simply lost. Server or the sender do not have any way to know whether this data which I sent was successfully received or not, right? So that is what you mean by the connectionless and unreliable service, right? This is what you mean by unreliable service. सेंडर को कभी पता नहीं चलेगा कि जो डेटा मैंने सेंड किया वो वहां पे पहुंचा कि नहीं पहुंचा. अगर वो पहुंच गया है तो उसका क्या हुआ, मतलब उसमें एरर है या विदाउट एरर पहुंचा है. It doesn't have any mechanism to check. There is a lot of background noise. Who is this guy? Arshad Vora. Arshad Vora is required to mute itself. Arshad Vora is required to mute himself. We are getting a lot of background noise from your mic. Okay. So now how is the data is received and sent using UDP, right? So the data is actually sent and received using a queuing mechanism, right? So every process requests a port number from the operating system. The one incoming queue is generated and one outgoing queue is maintained per port number or per process, right? So when the process is sending and receiving data from the transport layer like this, so there are two queues maintained. One is called the outgoing queue and one is called the incoming queue. And through this particular queuing mechanism, the process, the communication or the transfer of data between process and transport layer happens in, right? So one queue is maintained per port number, right? So port number basically refers the client process, right? So for every client process, you have a port number, and for every port number, we are maintaining the pair of queue. One is an outgoing queue and the other is a incoming queue. So whenever the process want to send data to TCP/IP, it will put it into the outgoing queue. And whenever the data is received by transport layer and that data is corresponding to this port number, the destination port number is 52000, then this particular data is placed onto the incoming queue, right? So that through this incoming queue, the process would be able to read that data further, okay? So one process, one incoming queue and one outgoing queue is maintained per process, per port number. So client process sends a message to the outgoing queue by using the port number, and UDP removes a message from the outgoing queue and add up into the UDP. So how does the UDP protocol works in? So UDP protocol will check, is there any data available in the outgoing queue? Yes. Then it will remove the data from the outgoing queue. It will formulate a UDP packet. How does it formulate a UDP packet? By adding the header information. So it will add the port number, source port number, destination port number, UDP length field and checksum field. It will add it into the UDP header. So after adding in the UDP header,
with the data, you generate a UDP segment, and then this UDP segment is in turn handed over to the network layer, right? It is the layer below the transport layer. Okay, so the client process sends a message to the outgoing queue. So client process simply writes down the message to the outgoing queue, right, using the source port number. The UDP removes this particular message from the queue, adds the UDP header, generates a UDP segment, and then it will hand over this particular UDP segment to the IP layer, or it will hand over to the network layer. Now so this is how the message is sent, right, on the network layer. Now when the message is received from the network layer, so when message arrives is from the network layer, that is the IP protocol hand over the message to transport layer, right? The UDP checks the destination port number, right? What is the destination port number of the received data, right? And the second thing that it will do is it will check, is there any queue exists which is corresponding to the destination port number. So when you receive a data which is having a destination port number equal to 52000, is there any queue, incoming queue available for it? Yes, there is a queue available, means there is a process listening on that particular port. If that is the case, then you remove the UDP header, you extract the UDP data, and then you place that particular data inside the queue, right? And the client process will see that, okay, there is some data available in the incoming queue. So client process will then read this data from the queue and process the data, right? So that is how the queuing mechanism is used in order to send and receive data, right? So if there does not exist any queue corresponding to the port number, it simply means that there is no process which is right now listening to this particular port number, and therefore that data is simply discarded, right? Assuming that we don't have any process which is listening to that port number, so that data would be simply discarded by UDP or at the transport layer. Now remember, again, when you discard the data, you do not notify the sender, right? Because it is connectionless, it is unreliable. So you don't have to notify anybody that you are discarding this data because the queue does not exist, right? Or maybe you will be discarding this data because the checksum value is not correct, or the checksum value is not matching. So before placing this data onto the queue, you have to verify the checksum. So when you receive the packet, UDP packet, you verify the checksum. If the checksum is correct, you find out the destination port number. You find out, is there any queue exists for the destination port number? If so, you extract the data from the UDP packet or UDP segment, and then you put that data into the incoming queue for that particular port number. And then the client process or the receiving process will read the incoming queue and will read the data from that particular queue and process the data. So that is how the mechanism works here, right? So that is called the queuing mechanism, which is implemented in UDP in order to interact or in order to make communication between the client, the process, right, and the transport layer, right? So that is how these communications are happening. In fact, I hope whether you know it or not, maybe you probably will be exposed to this in greater detail when you talk about distributed computing or like subjects. Queuing mechanism is a very generalized mechanism that Unix operating system uses in order to communicate between processes, right? So there are two processes running on the Unix operating system, and one process would like to send some data to another process, right? So queuing is one of the very shared memory and queue. These are the two important technique that is normally used by the Unix operating system in order to communicate data from one process to another process, right? So there is a common queue maintained there. So process A goes and write data into queue, and then the other process B will go and read the data. We'll say that, okay, is there any unread data available in the queue? Yes. Then you read that data, you remove that data from the queue. So at one end, you keep on writing data in the queue. On the other end, you keep on removing data from the queue, right? So that is how a common queue mechanism is used to transfer data between two processes on the Unix operating system. Okay. So similarly, this is also the case, like you can consider this as a client process, right, or the process which is trying to send or receive data, and the transport layer itself is running as a network process, right? So your network TCP/IP networking stack itself is running as a process, right? So that particular process is the running inside the operating system in the kernel mode, and this is a process which is running in the user mode. So these two processes communicating with each other using the
queuing mechanism, right? So it is not specific to TCP/IP, but rather in general, this is how the Unix operating system used to communicate between two processes, or used to communicate between processes which are operating in the kernel mode and the process which are operating in the user mode, right? So that is the general mechanism, right? So again, let me just summarize what is UDP. It's a simple request response communication. There is just send and receive, right? Nothing else. If you want to send data, you will send it. If you want to receive data, you only have a receive function here, nothing else. No flow control, no error control, no connection establishment and release mechanism, right? So that is simple, connectionless and unreliable mechanism. It is suitable for process with internal flow control, right? So if the application itself is maintaining the flow control, then in that case UDP protocol can be used at the transport layer, because the application layer is maintaining the flow control. Like for example, trivial FTP or TFTP. So TFTP is basically implemented using UDP, but TFTP is the protocol where you require this reliability, right? You cannot say that, okay, I have sent it a file, but I don't worry whether the file is received on the other end or not, right? It is not like that. In the FTP protocol, we need to make sure that when we upload a file or when we download a file from the FTP server, that file is actually intact and that file is actually correct. So how do we do that, right? Because TCP is not providing this connection oriented and reliable service. So it is the job of the application software now to handle this, right? So the trivial FTP or TFTP protocol or application itself maintains the internal flow control. TFTP maintains the internal reliability of data, right? But the actual transmission is happening using UDP, right? So this reliability and flow control is actually part of the application. But at the transport layer, the mechanism is connectionless and unreliable with the help of UDP. So likewise, if there is any application which is maintaining flow control at the application layer, then they can use UDP protocol at the transport layer. It is suitable for multicast communication. When you want to send one data is to be sent to multiple receiver, right? Then it is suitable. It is suitable for SNMP, right? That is the error messages and control messaging network management protocol, right? It is suitable for those kind of applications where the size of the data is very small. You want to send small updates, right? For example, routing table updates or some other updates. So these kind of protocols again can be used. The UDP protocol can be used. So basically, when you have your data to be sent frequently as an update, but the data itself do not contain much of the information. It's a very small data. It is the reliability is not a very strict requirement. That is, it is okay if you miss some of the data packets, if you lost some of the data, that is fine, right? Then you can actually go on using the UDP protocol, right? So your requirement is that you want to send as many data as possible without the overhead, right? So you want to send your data as fast as possible without any kind of overhead, but it is okay if you lost some of the data in between, right? And the size of the data is very small, then it is very much possible for you to go for using the UDP protocol, right? So this is what the UDP protocol is. Okay. So next is a TCP protocol, right? So TCP protocol is basically a connection oriented protocol. It creates, first of all, a virtual connection between two devices. So before actually transmitting data, the TCP protocol has to establish the connection between the sender and receiver. So what do you mean by connection? The connection means that the sender agrees that I am ready to send. At the same time, receiver also agrees that I am ready to receive. So the connection means we are getting confirmation from both sender as well as receiver. Sender is saying that I am ready to send, and receiver is saying that I am ready to receive. Then and then the communication could continue further. If your receiver is not ready to receive, it will revoke, it will refuse the connection, then the communication cannot happen, right? So that is what you mean by connection oriented. You have to, before transmitting anything, you have to make sure, first of all, that your receiver is there on the other end and your receiver is ready to receive data. Then and then you can send data to the receiver, right? So that is called connection oriented. Second is reliable. It is implementing reliable mechanism, right? Error control using flow control and error control. So we already know how to implement reliable mechanism. There is something called sequence number. There is something called acknowledgement number. So every segment, we called it TCP segment. So now there are two segments, UDP segments and TCP segment. UDP segment means data sent through UDP, right? And TCP segments means the data sent through TCP, right? Data divided into chunks, right? These chunks are in turn sent through TCP, that is called TCP segments. So every TCP segment that we send out, we are identifying that with a unique sequence number. And as soon as the packet or TCP segment is received on the other end, the receiver also need to send an acknowledgement saying that I have received a particular TCP segment with this particular sequence number, right? So that is called the acknowledgement part of it. So using this sequence number and acknowledgement number mechanism, we are able to do flow control and we are able to do error control, right? What do you mean by error control? That if we do not receive an acknowledgement, we assume that the data contains an error or the data is lost, so we have to simply retransmit that data, right? So whatever concept we discussed during the data link layer, all those concepts like acknowledgement, sequence number, retransmission timer, all those concepts are applicable here. They are exactly the same. The only difference is that at data link layer, we are only talking about the current host hop and the next hop. We are only talking about the current node and the next node. Whereas here, we are talking about end-to-end communication, that is the source process to the destination process, right? हम लोग एंड टू एंड कम्युनिकेशन के बारे में बात कर रहे हैं. हम लोग फ्लो कंट्रोल की बात करते हैं, लेकिन एंड टू एंड फ्लो कंट्रोल की बात करते हैं. हम लोग एरर कंट्रोल की बात करेंगे, लेकिन एंड टू एंड एरर कंट्रोल की बात करेंगे. जबकि डेटा लिंक लेयर में हम लोग होप टू होप फ्लो कंट्रोल और होप टू होप एरर कंट्रोल की बात करते हैं. इट इज ओनली लिमिटेड फॉर अ सिंगल होप. उस होप के बाद में डेटा का क्या होता है, data link layer is not responsible for looking into it. Okay, but transport layer obviously will do this mapping process to process, that is end to end mapping, end to end communication जो होता है, starting from the source process to the destination process, whether the data is received or transmitted correctly or it is received on the other end correctly. So that end to end flow and error control mechanism is what is implemented by TCP, right? लेकिन again I am saying the idea is very similar to what we did in the data link layer. खाली इतना है कि उसका स्कोप हम लोग बढ़ा रहे हैं. अभी वो end to end हो गया है. Instead of we are talking about one device to the next device, now it is end to end, the source process to the destination process, right? So that is the case. So in the next class we will see the TCP service, TCP features, how TCP actually establish connection, how the segments are generated, how the sequence number are allocated to the segments, how TCP actually maintains established connection and terminates connection, the connection establishment process, and we'll also talk about what is flow control and error control mechanism in TCP IP, right? So in TCP protocol, right? So that is what the content of the next class. So I hope you would have enjoyed this session. So if you have any doubt related to UDP, you are free to ask your questions, your doubts. Otherwise, you are free to leave the class. If you don't have any doubt, you can leave your class, right? But if you have any doubt, feel free to ask your doubt related to UDP.